Welcome to Shop Data's presentation of QuickDuct CAD, the quick and easy way to detail your HVAC projects in 3D. Shop Data Systems Incorporated has been providing software for the construction industry since 1975 and now boasts over 3,000 customers worldwide. We not only provide state-of-the-art CAD products, but also products to run your plasma machines, lasers, oxy-fuels, and water jet machines as well. Anything your shop needs, Shop Data can handle. QuickDuct CAD is a product born out of the fabrication side of HVAC and is developed and designed to allow its users to draw HVAC in 3D for coordination purposes. CAD allows you to download your objects to CAM. The CAM product can then run your plasma machine. QuickDuct CAD resides in AutoCAD, and we work from AutoCAD 2002 up to the latest versions of AutoCAD. Today's demonstration is going to be in AutoCAD MEP 2009. And because we are so integrated into AutoCAD, you can use all standard AutoCAD commands with your ductwork. You can use move, copy, array, mirror, any standard AutoCAD command you are used to, you can use with our ductwork. Across the top of the screen here, you're going to see our ribbon toolbar, showing you the different tools available to you to use with our duct. Down the left, you're going to see our fitting palette, currently showing you our rectangle items. And we have a round palette as well as a flat oval palette. For today's demonstration, we're going to route around our 2D office floor plan here. Just to give you a roadmap of what we're going to do, we're going to come off this unit, elbow into the ceiling, elbow back to our hallway, and route around the corner. Make some changes, make some edits, and throw a tap run into this room here. So I'm going to zoom into my unit, say new duct, tell it to start with a canvas connection, and tell it to use my primary supply line. Down the command line, it's asking me for a start point. I'm going to tell it to use this opening here. And because this unit was drawn with our program, it's smart enough to know the opening size, the elevation, and the direction of airflow. Say OK to that. And we'll zoom in here to get a good idea of what's going on. This is our elevation. This is our elevation tag, showing you the elevation of the duct from the floor to the bottom and from the floor to the top. What's unique about our elevation tag from our competitors is that when you move the fitting, not only does the tag move with it, but it automatically updates itself as well. So you never have to guess at how high you are drawing your duct. Zooming in a little bit closer, you're going to see some of the fabrication intelligence that QuickDuct CAD contains. This flange size is user specified. You can specify the size of your flange that you want to see, or if you want to see one at all. Same thing for the gasket spacing here. You can specify the size of your gasket, or if you don't want to see any spacing at all. This guy here is our navigator. It's pretty much a "you are here" icon, just showing you which duct you're drawing on and what direction you're drawing. We'll zoom out a little bit more here and just keep on drawing. I'm going to tell this guy to go with a square throat radius heel. Down the command line, you're going to see it prompting for the data that it needs to draw the fitting. We call this area our smart prompting because you have control over it. Point. Rotate that guy 90 degrees to get pointed up, and then we'll put on a full joint. Continue here with a square throat, square heel. Also, you're going to see that my defaults popping up down the command line, 6 inches for straight 1, 6 inches for straight 2. Again, you can specify these defaults and whether or not you want them to prompt you. We'll zoom in a little bit closer here, and you're going to see my air type symbol. When you set up your duct line, QuickDuct allows you the ability to specify whether that duct line is going to be a supply line, return line, or exhaust line, and then applies the correct air type symbol for that type of duct. We'll zoom out a little bit more here and keep on going to our hallway. Throw in a full joint, and throw in a cut joint, and you're going to see my rubber band line following my cursor, giving me a preview of that fitting length. All we have to do is stretch this guy to how long we want it. But something you're going to notice is as I stretch this guy past a full joint length, it's going to automatically break this run into full joints for me. That way you don't have a 600-inch long joint that the shop gets mad about and has to build. We'll drop this guy in our hallway here, tell it to be 24 inches long. To keep going, I'm going to do a radius Y line during your prompt. Smart prompting allows us to do another feature we call our heads-up view. It's going to morph the fitting based on what you type in. Right now it's prompting me for my end 3 width, which is this end here closest to us. If I'm going through here real quick and I type in 2 instead of 22, you're immediately going to see the human error there on the screen. To fix it, I simply back up one prompt and say 22, and we're back in business without having to redraw the fitting. Likewise, I'm going to change my radius from 28 inches to 22 inches, and you're going to see that immediately on the screen. Enter through our smart prompting here, and then we'll tell it to do a full joint on this side of the Y. Then to get back to this side of the Y, it's a simple process. Simply say attach duct, grab this opening here, and we're off and running. So at this point, then I want to do an auto route around my corner here. I'm going to scroll down to my auto route section, say radius elbow run, and you're going to see that same rubber band line pop up and follow my cursor. We're going to stretch this guy past our corner and drop it outside the wall here, down our hallway. QuickDuct then goes from your start point to your end point and places full joints where it's needed and places a cut joint where one is needed. And it goes all the way down to my end point where I told it to stop. See this guy in 3D. Now at this point, we're not unique from anybody. Every CAD program can draw duct. We draw a little bit easier than the other guys, but every program can draw duct. What sets us apart and what's unique about us is our ability to edit the duct once it's drawn. Let's say for argument's sake the steel is in your way. I'm sure it never gets in your way in the real world. Let's say for the demo purposes it's in the way, and we have to move this run of the duct 12 inches into the air. We'll zoom in here to 3D so we can get a better idea of what it's doing. We don't need this guy anymore. We're going to put in an offset. I'm going to delete it. And I don't want this big of a gap between my elbow and my joint, so I simply grab this first piece, click on its grip, using standard AutoCAD, and say move backwards 20 inches, and into the air 12 inches, and it moves all duct connected to it. So I don't have to move each individual fitting. Then let's say before I connect, I want to make a size change to this run of duct. I'm going to edit the first fitting. Say not 22, but actually I want this guy to actually be 20 inches. As I hit the tab key, you're going to notice my connectors change from TD to S&D automatically. This is based on my shop standards, my 2-inch water gauge. We'll say OK to that, and then the program can automatically ripple this change down the rest of our leg. So we don't have to edit each individual piece of duct. Imagine having 500 pieces of duct down this run, and you have to move and edit. Well, you don't want to grab each individual piece. There'll be 500 clicks that you don't need to do. You simply edit and move the first piece of the duct, and it goes downwind and changes every duct that is connected to it. Then to fill the gap in here, we're simply going to say connect from here to here, and the program automatically changes elevation and size for us and determines the best fitting for the scenario. But let's say I want to override that selection and actually use a radius OG. I simply specify my radius OG, and the program substitutes the fitting. It is going to automatically place an elevation tag when elevation changes, as in this case. It's also going to tell you the amount of elevation change on your offset, telling you it's going to be top up 12 inches and showing you the direction of offset with this arrow. It also automatically puts in a length for me for this offset and automatically puts in the text showing me a size change on this joint. So now we're ready to do a tap run into our room. Panning over here, we're going to jump into a different view in our 3D, and we're going to zoom in. Now in this room I've got two 3D diffusers already drawn. I'm simply going to say add tap to this fitting on the left side of the fitting. Start with a 45-degree tap and line it in between our two diffusers here, say 12 by 12. We're going to throw on a couple full joints to get us back behind our two diffusers and cap this branch line off. Then we'll zoom in here and do our add tap command one more time. on the left side again. This time we're going to use a spin in and line it up with our diffuser, tell it to be 10 inches in diameter, and delete my navigator because I don't need it anymore. So now when I do flex from my tap to my diffuser, I simply say add flex from here to here, and the program is then going to do the calculations for me and automatically put in my 3D flex to my diffuser. We'll zoom in a little bit so you can see how that looks. And now, because we are integrated into AutoCAD, I don't have to redraw this tap and the flex on this side of the duct. I can simply grab the objects I want to mirror, type in mirror in my command line, and then give it its mirror line, and it places it for us. Zoom in out a little bit. Now let's say I want to come over here to this radius Y. I want to get rid of this full joint. I want to do some round at this point. Again, we're going to say attach duct to this opening, and we're going to scroll down to my squared around section. Just say center line squared around, and we're going to do an 18-inch round, 10 inches long. And I want to route around this guy. We're going to do my round auto route here. Do a gourd elbow spiral run. Place it down my hull. It places my round run there with my gourd elbow using my own defaults for my gourd elbow. I'm going to come in here now and say I want to do a lateral T. I'm going to grab this guy and tell it I want it the N3, which is my tap, to be 10 inches in diameter. I want to rotate this guy around 180 to get it pointing to my room, and I want that tap to be 90 degrees off my body. Then I want to keep going here, and I'm going to do some oval. I'm going to scroll down to my reducer section and tell this guy to be a center line reducer, and I'm going to draw some 22 by 12 oval. One thing you're going to see, as soon as I do my 22 by 12 oval, you're going to see a pop-up here called possible oval sizes. This is something unique to our program where you can set up oval sizes based on your ovalizer. You can then specify, say, if my minor is 12 inches, these are the available major inches. If my minor is 12 inches, then here are the available majors that are close to my desired 22. I'm going to say 23 by 12. Say OK to that. Tell that guy to be 10 inches long. Then we can keep on routing around if we wanted to with our gourd elbow run and drop this guy down. So QuickDuct not only supports basic rectangle items that everyone draws, but it can also handle the complex round items as seen in our T here, as well as any oval items that you need to be drawn. So at this point, let's say I'm ready to download the fittings. But first, I want to run a couple of reports. Come in here to QuickDuct, say run a custom fitting report. It's going to crunch the numbers for us and then pop up a report showing us. It's going to crunch the numbers for us and then pop up a list of available reports that we can run on our fittings. So at this point here, I want to do a line takeoff. Say OK to that. It's going to show us a summary of what we've drawn so far. This guy's pretty complex and pretty detailed. We can make this report as simple as it needs to be. QuickDuct also supports equipment reports. So if you want to run a diffuser list or a VAV list or a unit list, we can support that as well. Any kind of report that needs to be generated in CAD, QuickDuct can provide. So now we're done reporting. We're done with all of our reports. We want to download this guy to our CAM product. But first, if you notice, I don't have any piece numbers on any of my duct. QuickDuct can handle auto tagging. It can tag it as you draw the fittings, or you can come back later and say, I want to tag it now. So at this point, we're going to say we want to tag it now. I'm going to say selective tag the whole drawing, and QuickDuct in a matter of seconds is done with that. As you can see, if we zoom in, I've got my settings to all like fittings get the same tag number. QuickDuct then goes down the trunk line, picks all those up, and then automatically picks up any branch line that you may have. Some of our competitors do not. Jumps back to our trunk line and goes down the rest of the line. Also goes down the other side of the branch, down our round items and our oval items. Now QuickDuct can handle a multitude of tagging options. Again, we can turn auto tagging on to where you can see tags as you draw your fittings. I currently have it turned off. Again, we can support same tag number for identical fittings, or you can uncheck this guy and get all of your fittings to have their own unique tag numbers. Even if they're, you can uncheck this guy and have every fitting get its own unique tag number. We can also support something we call assign tag number by branch. What this means is that QuickDuct will go down your trunk line. When it finds a branch, it'll then go tag down your branch line and then jump back to your trunk line. If you uncheck this guy, if you uncheck this option, QuickDuct will tag down your whole trunk line and then come back and automatically pick up the branches in order they were drawn. I'm going to uncheck have same tag number for identical fittings, say OK, and just say refresh tags. And it automatically places unique tags on all of my fittings. So now we are ready to download. I simply say download fittings. Down the command line, it gives me some options. I can either download the whole drawing or a certain section of the drawing. I can do it by layer or by duct line. In our case, I want to do a section. Save my text file to my desktop and simply grab, let's just say this area is the only area ready for downloading now. I'm going to grab that area, hit my enter key, and it's done. So now let's say 2 days have passed and you have to download the rest of the drawing, but you don't know what you've downloaded, what you have not downloaded. No problem. Simply say show downloaded fittings. QuickDuct then highlights in red every fitting that has been downloaded and marks in green every fitting that has not been downloaded. We can do this because QuickDuct marks fittings as downloaded behind the scenes in the program. What that means is that we can double check if it's been downloaded or not. So if you try to download the same fitting twice, there's a check there against human error. QuickDuct will never download the same fitting to the shop unless you tell it to undownload the fitting. You don't have to redraw the fitting or delete it. You simply say undownload fittings and say undownload everything. Now if we do show downloaded fittings, everything will be green and say ready to download. You don't have to delete fittings and redraw them if you want to undownload them. You simply say undownload. I'm going to tell all of my objects to go back to their by layer, and now they're back to the color that I originally had them at. So at this point, now we actually want to download the whole drawing to CAM. So again, I'm going to say download fittings, and this time I'm going to say all, and again I'm going to save my text file to the desktop. Now because QuickDuct downloads its files to a text file, your files are always going to be small enough to pass through email, store on the server, or store these text files anywhere you want. They're not going to be large at all and take up a lot of room, but as you can see, they contain all of the data that is needed for import. So now we want to import this job into our QuickDuct CAM product. Simply open up a job. Simply say new job and say demo video for my job name. Then I'm going to go file, import SDS CAD file, grab the text file where I stored it. We have a progress bar at the top left showing us how we're doing. This guy will then import all of the fittings as needed, and this guy will then import all the fittings as needed into our job, and as soon as they're going to be imported, they will be ready to nest. So we can scroll through here and just double check if we wanted to. See all the fittings that we drew and that we downloaded. One thing you will notice across the top, when I imported into my job, the CAD product told the CAM product, when I imported the job, it put in first floor, my zone is AH1, my batch is 1. the detailer can tell the product, a detailer can tell QuickDuct which area of the building he's drawn in, if it's the first floor, second floor, third floor, what zone he's drawn in. And then from detailing to cam to nesting to the label to the shop, all the way out to the field, everyone knows where this duct goes to, which floor it goes to, which zone it goes to, and which batch it's a part of. So at this point, we're going to say nest and tell this guy to nest. It's going to process all of my sheets for me. Then we'll take a look at the nest once it's done. And there she is. From 3D to 2D, QuickDuct handles it all. Thank you for your time, and if you're interested in a more detailed demonstration, please contact your local shop data sales representative.